Very warm welcome to today's eMeetup, to the Data Science eMeetup by Irium. To those who don't know me, I'm Theo, next to Maxime, one of the founders and managing directors of Irium. And I'm very happy to have you in the eMeetup today, Nikolaj. Nikolaj, you are a senior data scientist at MHP, one of the two big Porsche consultancies. And today you're gonna tell us something about scalable AI. I'm very looking forward to that. And since I know your slides already, and I know that you've got a "Who am I" slide in there, I'm gonna skip all the rest regarding your person. We'll directly give the word to you and say the stage is yours.
Thank you very much, and thanks for having me. Just give me a second. I'll present my screen. Please give me a thumbs up if you see the whole screen. Okay, thanks a lot. And I see your faces, so I can see the thumbs up too. Very nice. Great for having me. Thanks for the invitation today. I want to talk about the topic of scalable AI. I've been doing this for quite a bit of time, and the topic is something that's really important to me. So I've split it up into an agenda of around about 5 points for you. First, the introduction. So what it is about, why. And second, what are the challenges? Why is there even this topic? What are the challenges in scaling? And basically, possible solutions, how to go about it. The spoiler is already in the agenda. It's 4 topics I want to talk about. It's data handling and code, and also team and methodology. And in the end, I left some space for the wrap up and hopefully a discussion. If you have any questions during the presentation, don't hesitate to basically interrupt me. I think this is also very nice and can help clarify some things. All right, without further ado, introduction, motivation. Theo already spoiled it, so who am I? I'm basically working for MHP, which is an IT consulting company, known mostly for Porsche, but it's not the only client we have. I myself did a lot of NLP and NLU, natural language understanding projects. What I'm currently focusing on is basically data project management. So data-driven projects and everything that is involved from the other side, from the project management side. And the topic you will hear about today is also the operationalization of machine learning prototypes. So basically how to scale prototypes that have been developed. And let's start with basically why I found it very interesting to go into this topic and what's the motivation behind it. I think you're all pretty much familiar with machine learning, so I don't have to give you an introduction to it, just a few facts and figures that basically machine learning and data science is, of course, widely used. Basically everyone uses it, but the more novel the domain is that is utilizing data science, the more possible it is to actually use it. So for example, everything that is research and development is about finding out new stuff, and there data science can really help. But on the other hand, if you have domains where you have deterministic processes there that are really have to be interpretable and repeatable, and to adhere to compliance standards, then you basically have lower chances of utilizing machine learning or data science, as is the case, for example, in finance. Also, what I think some of you or most of you also have experienced is that developing a model is one thing, but actually deploying it into production is another thing. And you can see that most of the time it takes more than 7 days, and actually it can take up to a month for different teams to deploy their models. And the interesting fact is it does not really correlate to the size of the organization, meaning that basically everyone has this problem of deploying models, and that it can be something that we need to tackle. The 2 problems that are basically inside this are that it's time consuming to somehow wrap your model up, make a model freeze and deploy it into production or into a system which can use it. And also that you have to do it regularly. So whenever you get new data or whenever you have an iteration of updating a model and uploading it, you need to go through the whole deployment process again. And if you imagine that For example, around about a fifth of the survey teams take over 30 days to deploy their models. That basically means you just finished your deployment and you can actually start again, because that's how often you should get new data at least. And
Nikolaj, one question here.
Yes.
So for the deployment, this is recurring deployment, those numbers, or the initial deployment? Because I can imagine that setting everything up in a very complex environment, okay, it might in some cases, like those 5%, take more than 1 year to set up the pipeline, but then a redeployment of an update should go way faster. Or is this really, are those numbers for each deployment?
No, that's basically the initial deployment. I don't know if there's any recurring deployment times, or if people even deploy it multiple times, because this could also be the case. Once deployed, fire and forget, and then hope for the best. Could also be the case. I'm not sure, but this statistic I took is only for the initial deployment.
All right, thanks for clarification. Yeah.
Right, and the final thing, and which is actually pretty interesting to me, I have to admit, is basically the fixation on models instead of data. We're in a data-driven process, or rather in a data-driven environment, but most of the time we concentrate on making the model better. And that's actually something I found out that is also finally making it to let's say the R&D departments, is that basically you don't only concentrate on the model, but you also try to make your data better. So data processing, data handling, everything, data standards, so to say. Because in the end, the best model doesn't matter if the data is shit. So garbage in, garbage out. Everyone knows about it, but there's still this kind of fixation on making models very good instead of making the data very good. And I think it's very nice that we're basically turning it around and making the data better without neglecting the model. So this is also some kind of development I want to talk about. Why now this whole topic of scaling, and basically what are the challenges in it? This is like 6 points I took with you, and I hope some of you can identify yourself with some of those points, and basically have some input for me also, because this is basically just my experience. The first point, and you already saw it in the motivational slides, is model lifecycle management and model deployment. Basically, having a very complex model and a complex environment to deploy the model makes it very hard to actually manage it the first time, but you also need to reiterate. So whenever you have updates in your data, you have to deploy a model again, and you need to make it in a repeatable way. You have to make sure that your model always works, and you have to make sure that your model always delivers the results that you also want. And for this comes the next point, is the point of model monitoring. We all know the metrics of F2 score, for example. We know accuracy, we know precision recall, but what are the real metrics that decide whether or not a model is actually good in production or not? So basically, if you have, for example, not a classification model or regression model, but rather something that is for explorative tasks. So take, for example, recommendation engines that give you some kind of product. There is no real score because no one knows whether or not the results are proper or not. So how do you determine your model metrics? And that's something that's really difficult to take into account when dealing with models. Also, when talking about deep learning, I think the biggest challenge there, apart from the model complexity, is the topic of explainability. So how the hell do you debug your model if you don't know what kind of things are happening inside? And this kind of black box is still something that puts people off from utilizing it.
Well, shit, you're not even trying. Ah, come on, that's so freaking annoying.
All right, I don't think that's a comment for the presentation. Another point which also happens very often, and this also ties into the lifecycle management, is the topic of concept drift. So basically, the time you're done with your model, so to say, you basically freeze it. And this is the time that your model loses predictability power, because the data changes, the world changes around it, but your model is fixed. And the more time goes on, the more your initial assumptions into the model that get frozen, they might turn out to not be right anymore. And that's what basically is called concept drift, that the world goes on, but your model doesn't. And this is something that also need to be managed. And of course, in the end, a non-technical point, which is also very important, is the topic of team composition. Because I think a data scientist is mainly focused on developing the model and maybe deploying it into production. But there's also people that need to maintain those kind of things. And I don't know if you're willing to pay someone that is really focused on research or something like that to actually operate a model. And this is kind of a shift in responsibilities that also needs to be managed. Well, how to tackle it? I've identified, or at least saw from the projects I've done, 4 main areas to focus on to tackle this. And the first one should be obvious, but it gets neglected pretty often in my experience, is the point of data. So improving the data should be the #1 focus, not the model, but the data to actually make a good model. And with this comes also the code, because, well, pushing your numbers around manually is not very efficient and not very scalable. And that's why we need to adhere to coding standards, also follow basically best practices. This ties in with methodology. So it's not only about technical aspects, but also how you manage those technical aspects, because we're always in a team environment. No one's sitting in the dungeon and programming and deploying models, but rather it's a team and basically interaction between different departments. And this is also the final area of focus, is the team composition. So how could the teams or should the teams look like, and what are the defining success factors in this? Diving deeper into the separate topics, I first want to talk about technical aspects, data handling, and code. First things first, I think you all know your different domains and your data, and I don't need to tell you about the statistics and the data and everything, but rather seeing it from a overview perspective. The data has 4 main drivers that determine the quality of it, or rather the usability into models. I think the first point is domain knowledge. So data is always dependent on the context it is used in. So different data can be used in different contexts, and it's always dependent on what you want to actually achieve with it. That has an influence on what you basically want to do with your data preprocessing. So the same raw data set can be used in different aspects, and it's always important to actually understand what is the end goal, what is the kind of domain I'm in, and how do I use the data points. Also, for example, something like physical boundaries. You can't have a temperature smaller than 0 Kelvin, and this is also something you need to implement into your data. This is also domain knowledge. The other point is automation. So as I said, it's not very easy to make something to basically extract the knowledge from your data, but you also need to make it repeatable in a way, because you have to do it multiple times. Whenever you get new data points, whenever an update of the database, for example, occurs, whenever you add another column or something like that, it will happen. It will happen often. You have to make a repeatable process. And for this, you actually need to write code or automate your process. You can also use ETL tools. That does not really have to have code, but it need to be automated. And this is the other point, that it's going to be iterative. So that's why
I have a question there.
Yes.
So, I mean, as you mentioned earlier, from your point of view, many people spend, let's say, too much effort on tuning the models, whereas usually it's in the data. And I think I can agree, but I'm a little bit surprised that you put the domain knowledge more in the data realm. To me, that's like something that should be, to me, that's something that I try to accommodate for in the model. Maybe you can comment on that. So let's say, okay, so you know the temperature cannot be below 0 Kelvin. So rather than enforcing your model to respect that, you say you would put that into the data preparation, or
exactly,
the feature engineering, or
exactly. Then that would be somewhere in between. So if, for example, I filter out the data that cannot be used,
okay,
I need to have the knowledge about it.
And okay, so basically the filter criteria. Okay, yeah, sure. The filter criteria domain dependent. Okay, makes sense.
Yes.
Thanks.
Also, to add to it, everything that is concerned with feature engineering, I mean, that should be a rather big focus in my opinion, and this also ties into the data and the domain knowledge. All right.
Okay. Yeah, to me, the feature engineering and modeling, that's like a smooth transition.
Yeah.
But okay, thank you.
Okay, thanks for the question. All right. I talked about the basically the iterative data processing, and finally the last point, and this is also something that I think gets sometimes neglected, is the topic of data diversity. And with this, I mean, does your data actually cover what you want to predict? The most simple point is if you have, for example, product data that you want to sell to, say, adults, but your data that you use to train your model only has seniors, older people from 60 years onwards. You are never gonna predict that someone between 20 and 30 is basically going to buy your product, because your data does not have this kind of information. And this is also something that you actually need to consider into your data preparation. Is the case I want to predict even contained in my data set, or what are the boundaries of my data? So this is also something you need to really incorporate into your data preparation. Based on the availability of data, you also basically make a model, and this model needs to be implemented into some kind of system. And this is usually an application of whatever kind, be it mobile, web, backend, whatever. It usually has some differences to classical software applications. The difference is the following. A basic software application has 4 stages. They are also a circle, but it's more linear. It's basically, you have a design phase where you get your idea. Okay, I want to do this app, for example. You implement it, you deploy it, and then you monitor it. So basically whatever is happening, and then you redesign it and implement it again. Everything that is inside machine learning basically starts with the point that you want to optimize. You have some kind of data, you have some kind of problem, and you want to optimize this problem. You then basically go into the experimentation phase. So you find out, I have some optimization goal, I experiment, and from this you build a model, which you then train. You validate this model, you have to have a model freeze, you then deploy it, and then you need to monitor it. And whatever your monitoring metric is, you basically end up with an optimization. And as you can see, this process is definitely more complex. It has more influencing factors, and you need to watch out for way more stuff. So that's why the reason, basically, it all starts very simple, and the usual process of developing the prototypes with some kind of optimization is you get some documents from your clients, or you have some data lying around. It's usually in document form, because rarely I see people starting with a database access and pulling the data from there. You most likely will do some local programming, so whatever your script language is, and what you get is an integrated script. So we're talking Jupyter notebooks most likely. And well, the points are obvious here, but I still want to highlight them, is that it happens only locally what you're doing. So basically no one else has access to it unless you go with your laptop to them. Your data is document-based, so it's fixed, and you have no interfaces to other systems most likely. So it's all in a very closed environment. It's only available to you. And whenever you want to basically change anything, it's rather difficult, because you don't have to, you basically need to pull your data, you need to modify your script, and it's basically high effort. And to tackle this, I think a very simple way is basically that you adhere to coding practices. And I'm not really gonna tell you how to use your favorite language, but there's some basic principles that you can adhere to that makes your life, and everyone's life that is basically working with your code, also way easier. And this starts with basically 3 qualities that every great programmer has. And the first one is basically laziness, that you actually want to make your life easier and that you don't want to spend any energy doing it. The impatience, it's basically you're not happy when your computer is not working. And hubris, that's basically that you don't want to be angry because your people don't see your code as bad. So this is just tongue-in-cheek virtues, but I still think there are some merit behind them. And what this turns out is basically some very basic principles that you can follow. And I think the most important one of them is make your code readable. And for this, you can use such simple things as descriptive variable and function names. So for example, if you say y equals model.fit x, that's not very nice. I mean, we all know at this point of time most likely what it is, but that's not something you should do. So basically name your variables the way they are describing. Organize your code into functions and name them accordingly. So if you're, for example, using a code that is loading data, name the function load data. It's easy and it's descriptive. And using an IDE is also very much encouraged. I don't know which one you use, but use it, learn to use it. And please follow a coding style and don't do any clever tricks. Simple is best. So just following this 6 points, even to very much beginners, telling those things and basically practicing them also has led to a massive increase in code quality. And this in the end makes it way better for people to basically cooperate and deploy their code in the end. So what this can in the end look like is, for example, if you take your Jupyter notebook and then try separating those things that are actually contained in there. The first thing is, of course, processing logic that you need to extract. This is everything that is, for example, to do with Python, Pandas, scikit-learn, NumPy. But you also have, in the end, the interfaces that you need to build. So these are both internal and external interfaces. So internal, I mean, to database systems, and external to anything that is basically to access the model. So, for example, a Flask server or something like that for a website. And in the end, some kind of deployment. You can use a Docker container. You can push it onto a Linux instance on any of your favorite cloud providers. Does not really matter. But those simple steps, basically separating your logic and your interfaces from the code and your model, is what is the first step to actually make it deployable. What it then allows you is basically that your model is available to non-developers, that you have interfaces, and that it basically can now be stabilized and implemented into the systems that need to be. I know it's an oversimplistic view, but it's still, I think, the basic concepts that are there and I've seen over the different projects. Apart from the technical side, there's of course the human side, I would say, and it's both the team and the methodology to actually manage those people and those efforts the people are making to make the projects or products work. The first point is, yes, DevOps. I mean, it's a buzzword, but I think the most important are the three core principles that are contained within DevOps. Is first, collaboration. I've seen way too many teams not collaborate with each other, but rather stay in their own worlds, in their own silos, and in their own departments. And that's the core principle of DevOps for me, is that you basically bring those different teams together. So you have the data scientists, you have the IT department, you have domain experts, you have the IT and the business side, and you actually need to make them work together to bring it into success. Otherwise, it will most likely fail. And since we're all humans, we also need to communicate, and that's basically another point that is very important is communication, bidirectional communication, meaning the business has goals they want from the model. They should talk to the data scientists. The data scientists implement something. They should talk to the business about it. And in the end, you have also users that should use this kind of project, product, website, whatever. And those should also communicate the feedback back. So it should be a closed loop between all of those parts. And only then you can actually see, okay, is the metric I've chosen for my model even relevant for the users or not? Or should I change something? Is it even useful what we're doing here? And in the end, it's all tied down by technology. So basically automation. This whole process of deploying stuff, of developing stuff, of communicating, of pulling feedback, it can and should also be automated as far as possible, as far as it's basically allowed also for humans. Apart from that, there's also the point, and I've talked, I think, quite a lot in this presentation of team diversity also. And as you can see, the whole focus on this should be on an end user. So your model is never alone. It is always in a specific context that is used. And this context is dependent on an end user. It all should always start with a problem and with an end solution in mind. And this end solution should be used by someone. Apart from that, there's also different roles. Of course, the data scientist, that's the one developing the model. And basically, this role knows how to extract insights from the data. The help the data scientists need is from the domain expert, because as I said in the beginning, the data is always domain dependent. And the data scientist knows how to handle data, but he does not know the domain the data is in, most likely. And this is why we need domain experts. So basically I would say the functional experts. Apart from that, we also need to have a business side. So we're paying to get, we are getting paid to work, and the business is the one paying us, and they should have an interest in the model that we're developing. So that's why the people developing those models and applications should also talk to the business expert to actually see what kind of idea is behind it, and whether or not this model, this process, product, whatever, can be sold to the users. In the end, we should also have usually someone or role that is very good at programming, so to say, because the data scientist usually knows how to extract the information from the data, but not really how to make good software, as in speaking of roles. And I think that's why it also need to be tied down in technology with a software developer that knows what he or she is doing. Combining everything together.
I have a question regarding the team composition.
Yes.
Do you consider the role of a data engineer as being part of one of these roles, or is this like a supporting role outside of the team?
It depends on how you define your roles. I think that's always a different question. I've seen sometimes that the data engineering tasks are contained within the data scientist. Sometimes it has aspects of the software developer. It could also be the domain expert. So it's how you view this role, but I don't see it that it should be neglected. It could be contained into the software developer in this kind of slide here.
Okay, thanks.
Right. All right, tying it all together, I think the first point is the model lifecycle you have can and should be integrated into the DevOps, basically, approach that is the point of automation and the communication. So every step you take inside this should also be communicated and checked with the other departments to actually make sure that your stuff you're doing is useful and that it's actually following the goal you're trying to reach. The point of team diversity, as we talked in the previous slide, is a very important point, and it's usually the best projects or products are those that are made from diverse teams. And also that, automation. Try to automate as much as possible because it will make your life easier in the end. So basically, this is where it all comes together. So yes, I've seen, we had some questions, but still just to wrap up some points that we talked about. The first, the machine learning lifecycle is basically that you do have a software application, but the machine learning is application or model is basically a more complex version. So you need to learn how to manage it, and you should adhere to coding standards by doing this. The data that you're using is always domain focused. So you should also keep this in mind and try to automate your iterative data processing and keep it flexible. And as far as methodology goes, DevOps is kind of a good way to actually handle it, and can have great potential for machine learning. Yes. So far, that's it. Any more questions? Please go ahead. And thanks for the attention, of course, and the questions so far.
Yeah, thanks to you and the presentation so far. Virtual big applause. Yeah, as you said, I've got a few questions, but I'd like to give the opportunity to the audience to raise their questions first. You can put them in the chat or just unmute yourself as you wish.
Then maybe I will start with a question. I think at one of the first slides, you said that the project are basically about prototypes. Do you differentiate between a prototype or a POC and basically the final product, which is to be maintained for a longer period? Or is it like a natural progression in the ML model lifecycle?
Let's go to this. I think there is a difference in the context that the model is used in, because a prototype is more like most likely a greenfield approach. There's not many constraints you have from your whatever legal constraints, for example, your company constraints, whatever. So that's why it's more, you have more leisure, you can try out more stuff. But as soon it's, or rather before it even gets deployed into production, it needs to adhere to different standards, and they can be imposed by the law, they can be imposed by your clients, by the company you're working for. So it's more strict. And the people that you interact with during these different processes, they also change. So for example, when you're developing, it's most likely a small team that can work very fast. But as soon as it's deployed, you actually need to also make sure that those constraints, for example, are always kept. And there's also a switch from development sometimes to operations. And those are different roles. And I rarely see data scientists, for example, that are happy when they get told you need to operate your model. So that's why I think there's also a switch in roles. So this data scientist, for example, can be exchanged for someone that I would call a model maintainer or something like that. So yes, I do see differences in those different phases.
Great, thanks.
One question from my side. Maybe you could go back to the slide with the challenges of scaling.
Yeah.
There I took a note, for example, with respect to the explainability. I learned that there are various types of explainability, like degrees of explainability. And I'm interested in your experience. Is it okay if the decisions of a model are explainable by principle, like that the customer understands how it works, and then it's okay, but the individual decision is not explainable? Like I understood how a neural network works, but I, at the same time, cannot explain how this specific classification was made. Or does it really go that far that we need explainability, like in a decision tree, where I can really see, okay, it is this and this in this case, with those weights on the nuts, and therefore it's this classification, or like a Bayesian network where you can also like derive the decision in terms of a specific calculation. How deep does this go? What is the demand from the customer?
Well, it depends on the customer. There's sometimes cases where just very good results justify the means, or basically the model means, so to say. So you can use super complex autoencoders and no one cares as long as the results are very good. So for example, a very high accuracy. So then the result is the explainability. Is it good? Is it not good? That's enough. Sometimes there's there's really the case where you want to go on a case-by-case basis. So I think everything that has to do with, for example, text data, it should have a lot more explainability, because people like to read stuff and they want to know why a model did some kind of decision. So for example, sentiment analysis could be such a case where it's very interesting and very interpretable for us, even as humans. And the more that it gets interpretable for us, I think, the more it should also be explainable from a model standpoint. And this is where non-deep learning models go better, I think.
Is GDPR not also a problem in this regard? Like if you use deep learning models for decisions around final customers, and the customer basically has the right to be informed how this decision was made, then you nearly have to have the the requirement to have proper explainability.
This could also be a case. I actually have to admit I've never met this problem before, because the only GDPR problem we had, it was pretty explainable. So we could look, it was, for example, at TF-IDF. So we could see the features and it was really easy. But this is an interesting point. I've never seen this before. So thanks for the heads up.
Be warned, yes. Maybe another question to the experimentation. I know we haven't covered this here, but like usually it's like once you have a model in production, it like on the one hand you try to maintain it and adapt to the concept drift which is happening, but on the other side you also try to improve the model itself. So do you know of good strategies on how to operate multiple model versions and basically how to do the experimentation properly, like A/B testing or stuff like this?
I would love to give you an answer, but so far I've not experienced it. I'm still in the phase of basically making it all work.
The hard work.
Yeah, but I think you can just look at different software development practices that are already in place and just basically copy it.
True. Yeah, good point.
One more thing from my side. Maybe could you please jump to this rather animated slide with the various components? I think yeah, this one. They've shown various components that you use and should use. And my question is, when do you start with this big box of tools? So do you already build the very first prototype, like with a Jupyter script that maybe already has interfaces and a Flask server, etc., etc., etc.? Or is it first of all an ugly thing that gets killed after maybe 1 to 2 iterations? When is this transition point, if there is one?
Yeah, usually my process is make it work and then make it good. So it usually starts with a Jupyter notebook, but I think the first seeds get sown when you actually show it to someone else. So the point you actually have an interaction with someone else but yourself, that's the point where you can actually make it good. And I also have a kind of hybrid process where I still use Jupyter for the thing I hope it was intended for, and that's rapid prototyping. So basically trying out new stuff with some kind of model or data dumps, for example. But I also try to reflect it into the application. So whenever something works, make it good. That would be the kind of concept I'm following. But the exact point I can't really name it. It could be in the first week of the project. It could be in the first year of the project. Totally depends.
Right. So I'm especially curious in this question because when building the prototype, you convert understanding and knowledge into code.
Yep.
And then, okay, you take those pieces of code and bundle them into modules and make them nice and write documentation and write unit tests, all the software engineering parts. And now new experimentation begins. So you go back to Jupyter notebooks. And how do you avoid that this becomes a big mess? Like we tried at Irium to tackle this problem by combining mind maps for data structurization with code in terms of like linking both sides with links that also survive if you take code snippets from the Jupyter notebooks and copy them into .py files. So this is a very technical approach. Is there more to that? How do you do this that you don't get then lost in various Jupyter notebooks, .py files, documentations, in wikis, PowerPoints, etc., etc.?
I'm trying to reflect on this. I think the point is, if you have coding standards, you actually try to reflect them also into Jupyter Notebook, even if it is for prototyping. You also try to pass variables, you organize it into functions, and just following this coding principles, you make it easier to basically copy paste it. And then it's just work. I mean, refactoring is a thing in programming. So it means you basically have to go there and make sure it still works, although it looks different. And I think the same can be applied to this kind of thing. It's a lot of experience and basically work. And I don't really see a point of or a way of automating it. And I think the point that also needs to be considered is what kind of things are you actually bringing into the Jupyter Notebook and what kind of things should be kept in those, for example, PI files. So I think this kind of experimentation goes rather into the model domain. So everything that starts from a specific point, it ends at a specific point. So for example, data model is enter Jupyter, and then you get results. And these are the system boundaries, and everything else gets not touched until the experimentation in the system boundary is basically fulfilled. And then you should basically, hopefully, take the results and integrate them. I think this is kind of like the split of responsibilities.
Understood. All right.
And regarding the general life cycle, again, do you happen to have cases where you incorporate something like active learning and more dynamic approaches, where it's not that the model itself goes through the life cycle, but there's a constant exchange between additional information, small model update or a small model increment, and stuff like this? Do you have any experience with these projects, or are they fairly uncommon?
Not so far. I think they're still pretty academic, or at least what I've found out so far, because usually people are happy if they have data in a model that is working, and then it should get turned into an application. So the perspective changes. But if you have any experience with that, that'd be great to hear, because I think we even developed a tool for labeling data, but in the end, we just use it for visualization because we did not need it really. That's the case.
Oh, yeah, sadly, I have no experience myself.
Okay.
That's why I was curious.
We have time for 1 to 2 more questions from the audience.
I have.
Okay.
Yola, go ahead.
Okay, thank you, Maxime. I don't have a question, but could you maybe switch back to the slide on coding best practices? I found that very interesting.
Yep.
Thank you, perfect.
As you can see in the source for the virtues, it's pretty old. And
Pearl.
Exactly. And I don't think it really changed. So it's kind of an oldie but goldie, so to say.
So the Old Testament.
Exactly.
I have another question that regards, I think you mentioned the closed loop between all stakeholders. And I was wondering, how do you do it in practice? So I mean, in Jupyter Notebooks, you can do storytelling to a certain degree, but in my experience, it often involved, unfortunately, building a lot of slides based on some current state, which then, once I have an update, it's a somewhat tedious rebuilding of the slides. And what do you use? What has been the best compromise? Do you show your collaborators the direct Jupyter Notebooks or even the code? Or, yeah, maybe you can tell us a little bit about that.
the first principle is basically regular meetings, whatever that means for you or your stakeholder. It could be, for example, sometimes if your stakeholder is the domain expert, it could be, for example, in the daily, it could be a weekly, it could be monthly, every 3 weeks, whatever. Just, for example, sprint demos also. Point is, the format that you're using depends on your audience and the kind of knowledge your stakeholder has with the data science process, I would say. If he, for example, knows that there's data processing, that there's modeling, evaluation, and so on and so forth, you could show them the Jupyter notebook. But if they're have a very high overview of the stuff and don't have much knowledge into the data science, I think slides are really the best way of communicating the stuff, and that you basically rather talk in principles of the stuff you're doing and try to make it into business goals. So I think this transition from technical metrics to business metrics is the important point.
So you haven't found a way around the pain of building and re-updating slides then?
You learn to embrace it.
Okay, fair enough.
Yeah, no, I think that's always the point with people that are focused on technical stuff. Maybe there's some tools to make your life easier, but what I found is you basically have a collection of your own slides and you try to recycle them as much as possible and basically update them as you go. But no, I have not found a way around slides. I think they're still the best way to communicate.
All right, so I think we covered a lot of questions. Thanks again for this very informative talk.
Thank you very much for the discussion.
If I understood it correctly, we are allowed to share the slides, correct?
Yes, exactly.
So we're going to put them on the Discord server for everyone's review and appreciation. Thanks again, Nikolaj. Again, virtual applause. And I'd like to give a short outlook to the next week's eMeetup. Its title is Why Isn't Data Equal to Data with Mark Smith. The topic will be about data analysis in the financial markets. So really looking forward to that. If you're interested, sign up on meetup.com. And having said that, have a good start in 2022. Stay safe. Thanks again, Nikolaj. Very appreciated to talk. Hope to see you in person soon. All the best, and to all the others, master the complexity. Bye-bye.
Thanks. See you.
Thank you.
Thank you. Bye-bye.
Thank you. Bye.